Hello friends, thank you very much for watching this video. I am Mohamad, and today we're going to be discussing how we can implement circuit breaker policies inside our .NET services. We're going to start by implementing a retry policy, then we're going to be going through how we can implement a normal or a basic circuit breaker policy, and then we're going to see how we can implement an advanced circuit breaker policy. We're going to be going through step by step of why do we need them. We're going to understand the concept of a circuit breaker and how does it come into place, and then we're going to be seeing it inside the code of how we can actually utilize it. If you like this video, please like, share and subscribe. It will really help the channel. As well, if you'd like to support me, please consider supporting me on Patreon or buying me a coffee. With that said, grab your cup of coffee and let's get started. So before we get started and actually start doing the coding and building our circuit breaker pattern inside our code, let us understand why do we need it, the implication of not using it, and basically how it will serve us within our microservice architecture. So in this example here, we're going to have like some kind of an airline website where whenever a user want to do any booking, there's a lot of different services that can come into place in order for us to be able to support these bookings. So for example, from the graphical user interface that the user will interact with, we're going to have multiple services like payment, search services, user services, availability, points, authentication, and booking services. All of these will play a crucial role in the user journey when it comes to booking any types of flights. And we're not going to be focusing on all of that. We're going to be focusing on the simplest approach. Whenever a user want to look for a flight, the first thing that they're going to be doing is they're going to be searching for a flight. And within this application to search for a flight, we can see here that we have, first of all, the graphical user interface that the user will going to be interacting with. And this is going to be here. This could be like a React application, Angular application, etc. Doesn't really matter. And then once those users interact, they're going to be requiring some kind of a background service which is going to be responsible for doing all of the search. So this searching service here, it's going to basically go and check all of the available flights for this airline. It's going to check the calendar service where it's going to list all of the different calendar that's gonna or different flights within a certain calendar time and the prices and all of that. As well, we might have a caching service where basically we cache certain responses within those searches. So if the users do the searches over and over again for the same dates, we'll basically give them the cached response within a certain amount of time rather than trying to do the calendar service over and over. So we're gonna have these two functionalities. As well, we might have the payments where person might want to pay for their flights, so they can pay through any of those payment providers, and they might have an exchange rate. So if they want to book for example in dollars and their currency is in euros, so we need to make sure that we're giving them the proper exchange rate, so etc, etc. But within this example, we're going to be mainly focusing on this flow right here between the booking to the search to the caching and then the calendar service. So what happens if, for example, I'm trying to do a check all of the available flights within the calendar service, but for some reason the calendar service is not working? Something that we need to keep in mind is systems will always fail. So no matter what types of application we're building, no matter what type of technology that we're using, no matter what type of infrastructure, there's always a chance that the application that we're building is going to fail. There's always going to be a chance that something's going to go wrong, either from dependencies, either from the connections, either transient errors, either the code actually in the application is not working, database connection issues. There could be a lot of different scenarios of why our application might not be working. And in this scenario here, if for example our booking service is not working and we try to do a search and we click on the search, and basically the search service will call the calendar service, gets a 500, goes back to the user 500, the user will click again, and that's kind of a repeating cycle, and basically the user will not going to be able to get the results that they want, and they're going to be basically facing with a really bad user experience. And that's something that we don't really want. We want basically whenever a user is actually trying to utilize our service to have a really good user experience. That's the first aspect. The second aspect is whenever we have certain approach, we don't really want to bombard our services, which is down, with a lot of requests, because first of all, we're gonna basically doing a DDoS attack on our service. We're gonna basically shut it down. we're gonna basically reserve all of the resources for a service which is not working. We're gonna be propagating errors which is not really need to propagate. We want a way where we can actually let the service know, the search service know, that in case the calendar service is down, for it to stop calling it until it's back up again, and then we'll be able to do the calls. So we want a way where our service is actually this service here, the search service in this scenario. We want it to be smart enough in order for it to actually be to recognize that there is some kind of a failure, and once the service recognizes this failure, it will stop any connection going to the calendar service. Either it utilizes a different service, so we can have a calendar service v2, for example, which actually we can utilize, and in that case it will reroute all of the request from calendar service v1, which is down, to calendar service v2. If we have some kind of a caching methodology, it will utilize the information inside the cache rather than trying to always go into the calendar service one after one after one. So we can see that within this search service here, we need to make it smart enough in order for it to recognize all of that. But how can we do that? And well, there's a lot of stuff that we can do. So first of all, we can actually do some kind of a retry policy, as we said. So what we can do is within a retry policy, we can say like every 5 seconds, try to do another call on that service. If it is failing, another 5 seconds and do this retry. So for example, this is gonna be the logic that a retry policy will follow. So let's say a service is down, so we wanna get the calendar service, it's gonna start it, it's gonna execute the request. Once it executes the request, is it gonna get an error response? So in case it gets an error response, it's gonna basically, in case it does not get the response, it's gonna continue and we're gonna stop. But that's not the path that we want. We don't want to think about the happy path scenario. We want to think about the unhappy path scenario, that anything that might go wrong. So in this case, we tried to get that information from our service, but we did not. We got an error. So are we gonna do another retry? Yes, we're gonna do another retry. So in case we're gonna do another retry, did we hit the retry limit? So for example, if we're trying to integrate with a third-party service, they might able to give us some kind of a limit. So within 1 minute, we're able to only do 30 calls or 40 calls. If for example, our application has already exceeded that 40 calls, basically we're not going to be able to do anything. We're going to hit the error log and we're going to be ending the process there. But in case we did not hit the error limit that we currently have, we basically implement the retry policy. We can do an incremental wait. So for example, instead of every 5 seconds, we do an API call. We can do, for example, the first 1 second, then 5, then 10, then for example 20 seconds. So we do, for example, incremental waits between every single call in order for us to give the service that we want to use a bit of a breathing space in order for it to be able to start back again and actually execute. So once we did the incremental wait, we execute the request again. Are we still getting the error response? And basically we can see that we're going into the same path over and over again. And we're trying to basically here to try to go through the same process of trying to resolve this problem by doing a retry. And as you can imagine, if we don't have some kind of a mechanism where we're actually stopping this, we're just gonna able to go into the log and basically stop any request going through and basically DDoSing that service, because if the service is down for a full day, we're just going to be basically calling it for a full day, and that's not what we want. So how can we resolve all of that? So in order for us to address this, we're going to be utilizing the circuit breaker pattern. And the circuit breaker pattern is similar to what it sounds. It's basically a term that's utilized within electrical engineering, but it's also very useful inside our microservice architecture. So if we take a look at the main definition of a circuit breaker pattern, it means that it's a cloud design pattern to deal with non-transient failure in a microservices. So here we can see this in more details. So within my search service here, let's say I have my user interface who's trying to call a user who's trying to do a search for a flight, and basically we need to call the calendar service. So once the calendar service is not down and we basically have only the retry policy and available in place, what's going to happen? The error is going to be cascading across all of these different services. So first of all, the booking service service is gonna call the search service. The search service is gonna call the calendar service. Once it calls the calendar service is not available. We retry multiple times, still not available. The error is gonna propagate to the search service. Now the search service will propagate the error to the booking service. And we can see here this flow of cascading errors is gonna cause us a lot of problems, because first of all, if we're trying to check what's going on here, we are not able to see what caused this error, how can we resolve it. We're not going to be able to see easily the reason behind all of these failures, because we're going to be seeing propagation of the errors, and it's going to take a bit of time in order for us to figure out. This is an easy example here, but in real life scenario, when we have a lot of, like, I want to say hundreds of microservices attached to each other, and we have some kind of point-to-point as well as cascading error mechanism inside our services, we're going to be dealing a lot of problems. So in order for us to resolve all of this, what we want to do is we want to implement the circuit breaker pattern. And the circuit breaker pattern is going to be pretty straightforward in order for us to implement. So what does this mean? So whenever our booking service is calling the search service, then whenever it calls a search service, basically the circuit is closed. It means that every request is coming through. And if you remember, if we know, for example, once the light is on, it means the entire circuit is closed, so it means the electricity is able to pass. Similarly here, if the circuit is closed, it means that all of the requests is able to pass through, because it's basically a single line. So once a circuit breaker is closed, the request will be able to go to the search service will be able to call the calendar service, and the calendar service will be able to call the DB. But what happens if the calendar service is broken down and it's not working? So the calendar service will do 3, 4, 5 times to call the calendar service, 10 times, and after 10 times the search service is going to be smart enough to recognize that, okay, the calendar service is not working, I need to open the circuit. So once it opens the circuit, it means that no more request is gonna go from the search service to the calendar service. It's gonna basically eliminate all of these requests. So that way, whenever we are calling the booking service, whenever we're calling the search service, we're gonna return back to the booking saying that this service is not currently available, and we're going to be retrying in a certain amount of time. So this circuit breaker pattern is going to allow us to protect, first of all, the calendar service from being DDoSed, and basically we're going to be protecting the resources, so we're not actually wasting resources trying to do retries over and over again. And basically we are giving the initial service, which is doing all of these calls, the right information in order for it to actually propagate the data that it needs. So we can see the circuit breaker logic decide if the request from the booking front end will be passed through or rejected based on the returned error. So for example, once the request will go from the booking service to the search service, the search service will have the booking in place in order for it to actually recognize that is the connection to the calendar service active or not. If it is active and it's accepting requests, so the circuit is closed, we'll be able to send requests. If the calendar service is down, it's not accepting requests, the circuit is open and we're not going to be able to send any requests. So in essence, this is the circuit breaker pattern. It's a way where we're actually protecting our resources, and we are managing all of these retry policies that we actually need to do in order for us to keep on getting the information that we need from the broken down service. So what are the different states that a circuit breaker pattern will have to go through? So first of all, as we said, is the closed state. A closed state means that everything can go through. The application is running perfectly. All of the requests we are sending from service to service, we are getting back the response, and everything is going up to plan. So this is the closed service. Everything is fine. The traffic is able to go through those different services. And we can see here that we are able to call the service A is able to call service B as much as needed, and we can see the information is passing. So the open circuit is basically no calls are allowed, and basically in case something is not right, there is no service coming from service A to service B. As we can see here, there is nothing going between those two services, and these are the two prominent states. But what is half open state? And half open state will play a crucial role in when we are trying to check if the service that we are relying on is active or not. So going back to this example here, so let's say the search service is trying to call the calendar service. It called it like 10 times, it failed, and it turned the state of our circuit breaker from open from closed to open now. But after, let's say, a minute, we want to check if that service is active again. So what do? We make the circuit half open. So we don't let all of the requests coming in. We let certain requests come in. So we can, for example, if we're doing 10 requests a minute, we'll let 5 requests or 4 requests go through to the calendar service. If those requests are successful, then we actually change the state of our circuit breaker from closed to open. If those requests are failing, then we keep the state as closed and then we'll try after a certain minute. So the half open state allow us to test the connectivity between the us and the service which is failing, and to see if it's up and running again. And this is going to be the crucial part. So with the half open state, it means that we are not keep bombarding it with all of those requests. We are basically testing the waters. Is it up and running now? If it is yes, up and running, we'll resume the normal operation and we'll forward all of the requests. If it's not up and running, then we're gonna let everyone else wait, and then we're gonna try again in a certain amount of time. And this is the main 3 states that a circuit breaker will provide. Close, it means that everything will go through. Half open means that only certain calls will be able to go from service A to service B. Test the waters there. If it's running, we'll make the state closed. If it's not working, we'll keep it as open. And lastly, the open state where nothing is able to pass, and the request is just stopped there and they are not being propagated to service B. So now that we have understood what a circuit breaker pattern is, what is the different state that currently exists when a circuit breaker pattern, let us see how we can actually implement this inside our source code. So I'm gonna go back to Rider. And inside Rider here, I'm gonna close everything that I have added. So the project that I'm using is, we have already built it before. It's an API service that we currently have, and it's related to Formula 1. We'll be able to see the drivers and their achievements. And on top of all of that, I have added a new API, which is called Airline Service. Again, it's a pretty straightforward. It only has one single endpoint, and this endpoint will get us the available flights. And it's a pretty straightforward endpoint. It doesn't really do much except going to a static list, hard-coded list inside this service called calendar service in order for it to get. So let's see how this calendar works. So inside this calendar here, what we have is we have this calendar service, which basically get us a list of static objects of flights, which I hard-coded here, what gives us the arrival, the departure from, the price of the flights, and the flight dates. And these are all just different miscellaneous flights that I have added, and with different random prices, so we can just have like a static calendar service. And the nice thing about this is I have added some code where it actually mimic a downtime for a certain amount of time. I took the inspiration from Nick Chapsa's video, so thanks Nick. So basically here what I did is every certain amount of time the service will go down, for example within a random certain amount of time, like once from every 4 requests, it will give us the service down for 20 seconds, and then let's make it 25 seconds. So for every 4 calls we do to this service, one time it's gonna be unavailable. So let's run this and see what do we get. So now this is running. Let me go to Insomnia, and here I'm just gonna do send, and as we can see here, I'm able to get all of the response. So we can see the departure, the arrival, and the date of the flight, and the price of the flight, so on and so forth. So as we said, this is a hard-coded data. So now if I send again, it's working again, I got a service unavailable. So basically it just try to mimic a really transient issue that we might actually face when we're trying to do a call. So it's still failing because it's 25 seconds did not pass, and then if we keep doing that, if we give it after 25 seconds, it should be able to pick up again. Let's give it a few seconds, and now we can see we got back the response. So again, this is a simple API. It doesn't really do much. It just basically gives us the list of the flights, and basically it will give us also any problems that it might face here. sorry, it will mimic problems that we might face with a third-party service. On the other hand, our Nobre API, we have already built it before. If you're interested in learning how we've built it, I'm gonna link the video here somewhere. Or if you want to get access to it, you can get it through Patreon. And basically here, and all of the source code is available to my Patreons. So basically here, within this API, we have a controller where you have drivers and achievements. So what we're going to be doing is we're going to be building a utilization of the airline service within our API service. We're going to be basically going through the process of, first of all, creating the retry, see how we can implement the retry. Then we're going to be seeing how we can implement a circuit breaker. And then we're going to be implementing an advanced circuit breaker and all of that. So we're going to be going to step by step where we can see how we can implement all of these. So before we do that, let me stop running this application. And I'm gonna go here to my terminal. I want to install certain packages. So I'm just gonna navigate to my API application. And first of all, I'm just gonna do .NET build because I like to do .NET build. Let's see, everything is building successfully. Yes, we got a success. So here, let me clear this up. First of all, I'm gonna add some packages. So .NET add package. First of all, I'm gonna utilize REST Sharp. And REST Sharp will allow me to do API calls between the first service and second service. It's going to allow me to do HTTP calls. And the second one is going to be poly.NET. Let me clear this up. .NET add package. I'm going to say it's poly. And poly will give us the ability to do the retry, the circuit breaker. It's a fantastic package. So if we go right now to check if it has been installed, if we go here to APIs, edit CS Proj, and we can see they have been installed successfully. We have REST Sharp available and we have Poly available for us. Perfect. So again, I'm gonna clear this. I'm gonna do .NET build just to make sure everything is building successfully. Okay, perfect. So the first thing that I want to do here is inside my Formula API, I'm going to add a new directory and I'm going to call this as services. And inside my services folder, I'm going to create a new interface, and this interface, I'm going to call it the iFlight service. I can call it whatever I want, just for simplicity's sake. And this interface here, what we're going to be utilizing it for in order for us to add the one functionality that we need in order for us to see the calendar. So it's going to be task, list, and it's going to return a flight DTO. And the flight DTO, I'll show it to you right now. I'm going to call it get all available flights. I'm not going to take any parameters. And if you want to go to flights DTO, if I go to declaration, the flight DTO pretty straightforward. It has departure, arrival, flight dates, and price. Pretty straightforward, nothing really complicated there. So that's gonna be the interface. And now let's add the implementation for it. So I'm gonna call it flight service. I'm gonna add this. And within my flight service, I'm gonna utilize the iFlight service that I have. And oops, I'm gonna implement the members. And here we can see we implemented the get all available flight. The first thing that I want to do here is add the actual implementation in order for me to be able to call the airline service from my APIs. So I'm gonna make this async, and I'm gonna start by first of all declaring the URL of my endpoint. So I'm gonna put const string URL equal, and to get this URL, I'm just gonna go back to Postman and get the same URL that currently exists here. And this is gonna be the URL that I'm gonna be calling, and this URL belongs to the Formula 1 airline service. And then what I wanna do here is I wanna create a client. So I'm gonna put var client equal new REST client. I'm utilizing REST Sharp to call this airline service. And then here what I want to do, I want to build my request. I'm going to put var request equal new REST request. And I'm going to pass the URL here. So this is going to be the first thing that I'm going to be doing. And then once I created my request, now I need to initiate it. And I'm going to put var response equal await client dot execute async, and I'm gonna execute the request, and then I'm gonna say if the response actually here is not successful. So if it's not successful, is successful. So if it's not successful, I'm just gonna throw new exception, something went wrong. And in case it's successful, I'm gonna return JSON encoder, actually JSON serializer dot deserialize, and it's gonna deserialize a list of what was it called? Let's check it here inside the entities under common DTOs, common flight DTO, and we're gonna take here the response dot content. Perfect. And this is gonna be our service. Now what we're gonna be doing is we're gonna be injecting it inside our program.cs, and let's inject it here. I'm just gonna make it builder dot services dot singleton, add singleton, and I'm gonna put flight service and flight service. Perfect. Again, my favorite command, .NET build. Perfect. And now what I want to do here is inside my controller, I'm gonna add a new controller, and this controller I'm gonna call it flights controller, and I'm just gonna follow the simple implementation. So I'm just gonna inherit from base, and let's update this and fix those dependencies. Okay, perfect. So now I have this in place. Now what I want to do here is I want to make a private static what was it called, iFlight service. I'm gonna call it flight service, and I'm gonna initialize this inside my constructor. Oops. Oh, this needs to be read only, and now I can initialize it here. Perfect. So now inside my controller, what I did here is I have initialized my flight service, and now all I need to do is just create an endpoint that's gonna allow me to utilize this. So I'm just gonna put HTTP GET, and it's gonna return a public async task action result, and we're gonna call this get flights, and here all we're gonna do is gonna put var result equal await the flight service dot get all available flights, and then once we got, I'm gonna return okay, and I'm gonna return here the result, and we don't really need all of that. Perfect. And let's make it a bit simple because we're throwing, so we're gonna put try catch, and in case it's failing, all I'm gonna do here is return a bad request, and I'm gonna return the e.message. Okay, so let's try this right now. Again, I'm gonna put .NET build. Perfect. And now I'm gonna put .NET run. Now I have it running on local 5000. Let me go back to Insomnia. I have already added it here. We can see that I have localhost 5000 /API /flights. We're calling it, and I got something went wrong. If I do it again, oh, the other service is not running. So let's run this. Now that our both services is running, let's go back to Insomnia. Send, and we're able to get the response back. Let's send it again. We are getting the response back, but we're not getting the data here. We got something went wrong, something went wrong. We have to wait 25 seconds.
A few moments later.
And we got the response back. But why are we not getting the data back? Let's check it out. So now to fix that issue, all we need to do is we need to add a case sensitivity options. So var options equal new JSON serializer options. And all we're gonna be doing here is good property case insensitive. I'm gonna equal to true. And then lastly, I'm just gonna add it here. So I'm gonna put here options. Perfect. Now let's run this. So we're gonna start first by running our airline service. So let's run that. And then I'm gonna run my APIs. So let's debug them both. Perfect. So now both of them are running. If I come back here to Insomnia, I click on send. And let's remove the debugger for now. And let's click on OK. And we are able to see that I'm able to get all of the information through my service. If I click again, we can see something went wrong. Again, something is went wrong. We have to wait 25 seconds before we can actually try it again. So let's see that.
A few moments later.
We can see we got back the response. Perfect. So now that we know that our service is working and we are able to actually connect to all of those different services that we need, and we know that our API is actually able to do the request and getting back the information, the next step for us is we're gonna be actually start implementing the retry policy that Poly provides. So the retry policy that we're going to be implementing, we're going to implement it inside our flight service, and it's going to be a pretty straightforward policy. So first of all, what I want to do is I want to create a policy. So we're going to put private static, and I'm going to make it read only. It's going to be async retry policy. And the response type that we want to manage, if we take a look at what is this going to return to us, the execution, we're going to see it's going to be of type REST response. So that's what we want here, REST response. And then I'm going to call this my retry policy. And we're going to say equal, and I'm going to say equal policy. Let's fix this reference. I'm going to put policy dot under result, and then here I'm going to specify the result type, which is going to be of REST response. And then here I'm going to specify my request, actually my response type, and I'm going to say if it is of, let's see, I'm going to check the HTTP response of my response type. So I'm going to say the status code. I'm going to say if it's equal to HTTP status code dot too many requests, which is going to be a 429, which means we have hit the rate limit, or if it is going to be, actually we don't really need the int here. And here we're going to say if it is any types of errors, so I'm going to put response dot status code. It's going to be bigger than or equal to 500. So in case it's any of that, we're going to do wait and retry async. And I'm going to say that it needs to retry 4 times. And for the retry attempt, let's build it here, and we're gonna say console.writeLine, and I'm gonna say, let's do string interpolation. We're gonna say retrying due to error, and I'm gonna specify the attempt. Actually, I'm gonna put here attempt. I'm gonna put the retry attempt, and I'm gonna say the reason is due to an error. And then here what I'm gonna do, I'm gonna return a time span dot from seconds, and I'm gonna tell it that I need it within, let's say, every 15 seconds plus the retry. Actually, let's make it shorter, every 5 seconds plus the retry attempt. Okay. And now what I want to do is, once I have implemented this retry policy, I want to actually utilize this inside my service. So what I want to do is, I'm going to keep this for now. I'm going to comment it out and I'm going to implement it here. So I'm going to still have var response. I'm going to make it equal to retry policy dot execute async, and here I'm going to specify that's going to be async. And I'm gonna pass here my service that I want, which is gonna be, let's make it on the new line. Oops, no, it's not just response. It's gonna be await client dot execute async. And I'm gonna pass the request. And here, why does we don't need the new? Okay. So that's what we're going to be doing right now. So again, we have the await, all of this, and let's make sure this is awaited. Perfect. So now we have everything that we need up and running. We don't really need this anymore. Let's delete it. So now what we did here is we just did a retry policy. After 5 seconds, we're doing a certain retry amount. So the first time is going to be 5. Then 6, then 7, then 8, because we're doing 4 times retry. Actually, let's make this 10. And so we can see it. Actually, 5 should be fine. So first of all, let's go and run our airline service. Okay, perfect. Now let us run the API itself. Okay, great. So now that both are running, let's go back to Insomnia and let's try this. And what I want to do is I want to check the logs that are coming. So right now we got a response. Perfect. So now again we got another response. Now it should fail. And now what I can see, I have attempt 1 retrying due to an error. So now after 6 seconds, 7 seconds, we're gonna have attempt 2. So now what's doing is our retry policy is automatically keep on retrying that service. And we can see at retry 1, retry 2, attempt 1, attempt 2, attempt 3, and we can still see it's running. And now we're gonna see attempt 4, still running after the 25 seconds has passed. And we're gonna see here that we got back the response. So we waited it out basically. So the first one, it tried to run, it failed. Attempt 2, it ran, it failed. Attempt 3, it ran, it failed. Attempt 4, we're able to get the response because we have waited out. And that's going to be the key area here, is within this retry policy, with this incremental amount of time, we were able to see how these requests were going from one to another, and basically we have all of these attempts. But with all of that, we're still going to have a problem here, because basically, let's say the service is down for like, I don't know, 10 minutes or 15 minutes. And basically with this, what we're doing here, we're retrying for a certain amount of time, like 4 times. And basically what we have here is this retry that we are currently doing is gonna be only within the certain amount of time. But that's not gonna be helpful in case that service is gonna be, for example, rate limiting us after those calls. We can have a rate limiting even if the service is down, we're gonna returning a 500. So in this case, we need to implement the circuit breaker policy in order for us to avoid all of these types of problems, and basically making sure that we are avoiding to replicating the errors. Because basically, if I increase my service here, downtime from 25 seconds to 50 seconds, it's just gonna automatically drop without actually, and the error is gonna be propagated back. So now let's see how we can actually implement this retry policies, actually those circuit breaker. So in order for me to implement a circuit breaker, it's gonna be pretty straightforward. I'm gonna put here private static read only async circuit breaker policy, and it's gonna also return the same thing. It's gonna be returning a REST response, and I'm gonna call it a circuit breaker, or let's call it CB policy. Easy. And this is gonna be equal to policy dot handle request handle result, sorry. And then here we're gonna do the same thing. We're gonna make sure it's gonna be a REST response. And then here we're gonna basically make sure that the circuit breaker policy only execute on the failure. I don't want it on too many requests. Again, this is only for demo. You can do it however you want. So we can do here the response, and I'm gonna say if my response is a dot status code is equal to int response dot status code is equal to 500 bigger or equal to 500, then and this needs to be int. What we need to do is we need to put dot circuit breaker async, and then here I want to say it's gonna be 4, and I'm gonna specify the time span dot from 1 minute from minutes, and I'm gonna choose 1. So what happened here? So if what I'm doing here is I'm creating a circuit breaker policy, and basically what I'm telling it is this circuit breaker policy is going to handle a REST response, because this is what we're expecting back from the client execute. And I'm telling it here if the status code of my response is going to be 500 or bigger, what I want to do is I want to implement a circuit breaker policy, and I'm allowed to only handle 4 requests during a 1 minute time break. So basically during the break it's gonna stop for 1 minute. Actually, let's make it shorter. We'll keep it as 1 minute so we can have a realistic scenario. Then I'll cut the video so it doesn't have to wait 1 minute doing nothing. And basically I'm telling it that the amount of events that it's allowed to handle before breaking is 4. So it's gonna retry 4 times. If it fails, it's gonna stop for 1 minute. If it doesn't fail, and after that 1 minute, it's gonna retry again. So that's what we want to do right now. And how do I implement this here? It's gonna be pretty straightforward. So we're gonna update this to handle the retry policy. So to handle the circuit breaker. So I'm gonna keep this here, and I'm gonna put here circuit. Actually, it's gonna be CB policy dot execute async, and this is gonna be also an async request. So I'm gonna put async. And what I want to take right now, I'm going to take all of this, and I'm going to put it here. So what we're doing right now is inside my circuit breaker policy, I'm executing async. I'm telling it that it needs to execute the retry policies that I had before, and it's going to execute the retry policy, and then I'm executing the command. So as you can see here, we have embedding. So if we go back to my diagram, what we currently have here is, first of all, we had the retry policy. First of all, we had the API call. Then we had, on top of the API call, we had, let's bring this to back. We had the retry policy. So now the retry policy is handling the API call in case it failed. And now once we had all of that, the next step is we have the circuit breaker. Go back. And here we have the circuit breaker. So all of these are working together in order for us to get the response. So first of all, we're gonna have the retry policy. The second of all, we're gonna have, the API call, then we're gonna have the retry policy, and third, we're gonna have the circuit breaker. And all of these information that we currently see here, it's all gonna be working in conjunction with each other in order for us to have a seamless implementation for calling all of these different API. And this is going to be the first one. Then we're going to have the retry policy and then the circuit breaker, and we can see it here. So first of all, we can see that the first thing is we're going to have the circuit breaker policy, and then if we put this down on another line, then we're going to have the retry policy, and then the retry policy is actually calling the execute async. And because everything is async, we have to wait for await it all of them. So now that all of these are actually running in conjunction with each other and they are in the same order, so we have first of all the execution with basically the API call, then the retry policy, then the circuit breaker policy. If I stop this right now and run them all over again, so first of all, let's start by running my service. I'm gonna run this here. Perfect. Now I'm gonna go here and run my API. Okay, perfect. And now I'm gonna go back to my Insomnia, and I'm going to send, and we see we got the response. Another send, we got a response. Another send. If we go back to the logs now, we can see I have my first attempt of retrying, second attempt of retrying. It is still running. We have 11 seconds, 12 seconds. Now we are on the third attempt. Fourth attempt. And then we got the response. Perfect. Now what I want to do is I want to decrease the amount of retry, and I want to check the status of my circuit breaker. So let's see how we can do that. I'm going to stop both of them here. Stop all. So now what I want to do here is, before I do any of those calls, I want to check my circuit breaker status. So I'm going to put here if. So if not CB policy dot circuit state is equal to circuit state dot open, which means that we wanted to stop. What we want to do here is we want to throw new exception, and I want to say this exception, and I'm gonna say here service is not available, and we don't really need this here. Let's remove this. And I'm gonna put a breaking point here so we can see the actual circuit state. And I want to change this one here from B actually to from 4 to 2, so we can see the state actually change. So let's go back here. Let's run my airline service. So now let's try it out. Send. Circuit is closed. Perfect. We got the response. Send. Circuit is closed. Perfect. Send. We got the response. Now it should stop. Still closed. And we can see now if I click send again, we can see here the circuit is still closed because we're still going the 2 times. Send again. Circuit is still closed. Send. Circuit is still closed. Now we can see the circuit is open. So after that we have done two retries, and the circuit basically hit its limit. Now it's gonna be open. Now we have to wait 1 minute, and after that 1 minute we're gonna be basically retry again. So now if I click on send, we can see here that the state is still open. State is still open, and we got a bad request after that, because basically what I did is I tried to wait. So now if I call again, we can still, circuit is still open. We're gonna getting the service not available. Again, service not available. Circuit is still open. After a single minute, once that is done, we should be able to see the service is up and running again.
A few moments later.
And let's click one more time. State is still open. I wanna just keep on trying until we see the half open state, if we are able to catch it. Now it's open. Now it's closed. We can see here that state is closed again, and we are able to get the response type. Okay, perfect. So now this is going to be the main implementation of a circuit breaker policy. Now we can take this a bit step too far, and we can make this a bit more of an advanced implementation. So let us see how we can do that. And I'm just going to copy all of this, and I'm going to add this here. I'm going to call this advanced CB policy, and the only thing that we need to change is going to be here. So instead of handling a circuit breaker async, we're going to put advanced circuit breaker async. And the advanced circuit breaker async is going to take different items. So first of all, it's going to take the failure rate that we want to implement. So here we're going to say, for example, let's say we are doing 100 calls, or basically we're doing 10 calls. If a failure rate is more than 50, we need to implement the circuit breaker. So we'll put 0.5, which is going to represent the number of percentage of failure, and then it's going to ask us in which time stamp it needs to monitor this amount of failure. So we can say that for the time span, I'm going to say from minutes, we can make it as 1, and then it's going to say, okay, so we're going to have 50% of failure in 1 minute, but 50% of which amount of requests. So of 10 requests, of 100 requests, 1,000 requests, we can just say here 10 requests for now. And then it's gonna ask us, okay, what's gonna do after the break? So how long is gonna be the break for? So it's gonna do the circuit open for like 10 minutes, for 1 minute. So after that, how long we'll have the break? So we're gonna put timestamp from minute, and we're gonna put 1 again. So we can see here that this is gonna be the failure threshold. So we can see here we have 50% of threshold. Then we're gonna put the duration for 1 minute. So here we're gonna basically, what we mean here by stamping duration of how long, for example, failure within the certain amount of time. So 50% of failure within 1 minute. So we're gonna put duration of failure, duration to measure failure. And then here we're putting the minimum throughput. So 50% of 10 requests, which is gonna be 5. And then the number of break after we, duration of break after we hit the circuit breaker. Okay, so now in order for me to implement this, I'm just gonna change here from utilizing the normal CB circuit breaker policy to advanced. So in essence, this is what we have to do in order for us to implement circuit breaker. First of all, we need to implement the retry policies. Then we need to basically implement a simple circuit breaker, and then we can go through an advanced one. So let's do a quick recap on the code itself. So as we can see here, this is my service, and within my service, first of all, I have implemented my retry policy. And my retry policy is basically, what we did here is we have taken the response type. We have basically specified the types of HTTP requests that we want to handle for a retry policy. If it's going to be a too-many request, or if it's going to be anything above 500, we have specified the retry count to make sure that this is going to be equal to the circuit breaker later on. And then we specify the retry amount, and basically the incremental amount of time that we want to wait before every retry. As for the normal circuit breaker policy, we have basically here said that we're going to implement it only for 500. We said that we're going to handle it for 2, and basically we have specified it that the certain amount of time that we want to have the circuit open. And here we have the advanced circuit policy, where basically also we're handling the REST response. We're handling it only for failures, and we have specified the configuration for advanced. And all we have done here inside my service is for us to actually utilize poly in order for us to utilize the circuit policy. So for the normal circuit breaker policy, we have utilized CB, execute async the circuit policy, we're executing it, where first of all we're executing the normal retry policy, and then we're executing the API call inside the retry policy inside the circuit breaker policy, and all of these are being actually embedded into each other here. So we can see this is going to be the flow. First of all, it executes this. If it fails, it goes to the retry policy. If those fails, it will go to the circuit breaker policy. So all of that will work in conjunction with each other in order for all of these to work. I hope this video was helpful. Please like, share, and subscribe if you found it helpful. It will really help the channel as well. If you have any questions, please put them in the comments down below and we'll be able to address them. If you want to see how we can integrate caching into this, also please let me know, and I'll make sure to cover this topic in a later video. Again, thank you very much for watching, and have a great day.